So now what we're going to look at are the sum of two cubes and the difference of two cubes. What we'll find out is when we bump up to the third degree, so powers of 3, then both the sum and the difference of those cubes is going to factor. If we have a cubed minus b cubed, then it's going to be a product of a minus b times a squared plus ab plus b squared. Instead of being the product of two binomials, we now have the product of a binomial and a trinomial. The difference between the two formulas is very minimal. It's a sign in the binomial and one sign in the trinomial. The first step when we are trying to figure out how to factor a sum or a difference of two cubes is pretty much the same as what we did with our difference of squares. If we could figure out what squared minus what else squared and write that intermediate step in, then we could see our a and see our b from the formulas. So maybe I have the polynomial, the binomial, x cubed minus 8. If I recognize that x cubed is x, let me see if I can coordinate my pens here, cubed minus 2 cubed. I don't want blue there. I'm going to do this. 2 cubed. Then I can cut and paste. I'm going to get this right in a minute. I can cut and paste into my formula. I will get my red and my blue pens all figured out here in just a minute. Every place there's an A, and every place there's a B, I can figure out what to plug in those places. So if we have x cubed minus 8 cubed, or 8, that's x cubed minus 2 cubed. Then when we go to factor, every place there's an a in the formula, I'm going to put an x. Okay. Every place there is, I'm going to do this way, which hopefully doesn't get too confusing. Every place there's a b in the formula, I'm going to put a 2. Okay, then I need my signs. It's going to factor. Then in my final answer, if there's anything I need to clean up, I go back and get that done. X minus 2 I don't change at all. Okay. X times 2, I already wrote it in that order, but I wrote 2x. And 2 squared I'm going to call the number 4. When we look at that trinomial, that x squared plus 2x plus 4, it looks like the stuff that we factored in class on Wednesday. However, if we think for a while and we write down the possibilities, we'll find out that there are no 2 factors of 4 that add to be 2. So this trinomial that you have, that second piece, is not ever going to break down anymore. It's never going to factor. A lot of students will get to this step and then write equals and keep going. We don't keep going here. That's as far as we can go, and it always will be. Maybe I have y cubed plus 27. Okay. I'm going to go back to the red here for a minute and see the red and the blue and see if I can get this all in the right place again. Again, the only difference in the formulas are there are a couple sign changes. Overall, they have the same pattern to them. I'm going to have an a plus or minus b out in front. I'm going to have an a squared plus or minus ab plus b squared in the expression. Those aren't going to change. What's going to change are the signs, and that depends on what the sign is here in the problem. If we recognize that y cubed is y to the third power, not much to say see or translate there, then we can see that a is going to be y, or y is going to be a when we go to plug into the formula. The b is what we cube to get 27, which is 3. So when we go to factor this, every place there's an a, we're going to put a y. Every place there's a b, we're going to put a 3. And then we have to be careful to get our signs correct from the formula. Every place there's an a, we put a y. Every place there's a b, we put a 3. Now in our last step, we're going to clean it up. Instead of writing y3, we usually write 3y. Instead of 3 squared, I'm going to call that 9. And that's how we're going to factor y cubed plus 27. Now, just like on the others, these can get a little bit nastier, so we're going to do some examples of some of those. I am going to see if I can copy and paste my formula, and if I can drag it down. Oh, I can. I wonder if I can copy it onto... I can. Oh, let me not do that. I'm going to clone it. Where'd it go? And then I can bring my clone down here. Okay. Minus that little 3 right there. So let's say instead of something like x cubed minus 8 or y cubed plus 27, let's say that we have the expression 8x cubed plus 125. Sorry about the smushed writing there. If we recognize that 8x cubed, to get 8x cubed, we cube 2 to get 8, and we cube x to get x cubed. I've now figured out that my a, every place there's an a in my formula, I'm going to put a 2x. Now since 125 is 5 cubed, then that means every place there's a b in my formula, I'm going to put a 5. So when I start with a plus b, or if I have a squared and an a times b, there, every place there's an a in my formula, I'm going to put a 2x instead. Now, every place there's a b, I'm going to plug in my 5. So there's a b, I have a times b in the middle, and I have b squared at the end. Okay. Every place there's an a in the formula, I'm going to put a 2x. Every place there's a b in the formula, I'm going to put a 5. And when we go to clean it up, the 2x plus 5, there's nothing to work on there. But with the 2x squared, when I square an expression, that means I get to square both the 2 and the x. Now in the middle, instead of 2x times 5, I like to call that 10x, and 5 squared is the same thing as 25. The main issue here is for students to figure out what is A and what is B and get them plugged in the right place. If you can write this middle step in here, where you can see what A is and see what B is. If you need to color code things for a while, if you need to, however you need to do it. But the main issue is finding that A and finding that B. From there, then it's a matter of practicing plugging it in. at your desk, go ahead and look at 64x cubed minus 27 y cubed, and see if you can get that broken down into its a cubed minus b cubed and cut and paste into the formula. Pause the video and work on that, and then start it back up when you're ready to see the steps. (64) is 4 cubed, and x cubed is x cubed. 27 is 3 cubed, and again y cubed is just y cubed. Every place there's an a in the formula, we're going to put a 4x. Every place there's a b in the formula, we're going to put a 3y. Be sure that you use the formula this time that has the minus in between. And our a cubed minus b cubed formula says we start with a minus b. Then we move on to a squared plus a times b plus b squared. When we go back and clean it up, then we square the 4 and the x, put 4 and 3 together to call it 12xy, 3 squared y squared is there. Alright, I will email you the homework assignment from these two sections. Section 6.4 is actually just general factoring techniques. It mixes them all together. Sometimes there's just a greatest common factor. Sometimes it's a factor by grouping problem, or you create a factor by grouping problem, or maybe it looks like these. Okay, I will put the homework assignment in your email because I'm about out of time on my video. So give me a shout when I get back from break if you have any questions. Thanks a lot.